Multiplying decimals and the circumference of a circle. Let's talk about multiplying decimals. I'm going to start with an example. Let's take 0.2 times 0.3. Now if you look at that, some people want to say the answer is 0.6. That is not the case, because when you read this, that's taken same as 2/10 times 3/10. Think of fractions. 2/10 times 3/10. We're multiplying tenths. A tenth times a tenth is a hundredths. And so let's use fractions to represent this and multiply with fractions. So you can see the reason why you multiply fractions or multiply decimals the way we're going to. So 0.2 is 2/10 because the 2 is in the tenths place. 0.3 is the same as 3/10 because the 3 is in the tenths place. When we multiply fractions, we go straight across. 2 times 3, 10 times 10. That's what I was saying when you multiply tenths. Tenths times a tenth is a hundredths. Now, to convert this back to a decimal, it's all about place value. 6 hundredths. That means the 6 is in the hundredths place. There's the hundredths. There's the tenths. So we don't have a number there, so we use a 0. So 0.2 times 0.3 is 0.06. What's going on is, the way most people were taught, you count the number of digits after the decimal in all the numbers. Here there's 1. Here there's a 1. Since there's one number after each, or one digit after the decimal for each number, that means there's got to be 2 total in the answer. 1, 2. That's the process we're going to use. We're going to multiply numbers as usual. We're going to totally ignore the decimals when we multiply, and then we're going to count. And that's how many places should be in our answer. Here we go. 0.3 times 0.7. Totally going to ignore the decimals for now. 3 times 7 is 21. Then we're going to count one number after the decimal there, 1 there, for a grand total of 2. It means there's got to be 2 after the decimal in our answer. So 1, 2, so the decimal goes there. You don't have to put that 0 in front, but I'll try to all the time. Let's make this one a little bit easier. You want to? Let's just make that 5 a 0. Just so we can do the multiplication a whole lot faster. So let's take the 2.34 times 0.007. I can do that. I'm teaching this class. I can do that. So I'm going to totally ignore the decimals when I multiply. 7 times 4 is 28. Carry the 2. 7 times 3 is 21. Plus 2 more is 23. Carry the 2. 7 times 2 is 14. Plus 2 more, 16. When I count, I'm going to count both numbers, the total number of digits after the decimal. That one has 2 after the decimal. That one has 3. Total there's 5. Right now, 1, 2, 3, 4, I have 4. That means is I gotta put another decimal or another number in front of it. I'll use a 0 as a placeholder, and then the decimal. That gives us 1, 2, 3, 4, 5. And that's the answer. Now the next couple of examples I'm going to show you, these are not required to know, but they can make life a little bit easier for you, a little bit faster. Let's do this one the long ways, and then hopefully you'll be able to see the shortcut way. We're going to take 100 times 0.3. So we're just going to take 3 times 100, which is 300. We got one number after the decimal. In case you're wondering, the decimal's on the end, so we don't have anything after that besides zeros. We're not worried about zeros. So we have one number after the decimal, which means we put the decimal there. So the answer is 30. The fast way is to notice that when you're multiplying by 100, it's going to make this decimal a bigger number. And then the way you can do it that's a whole lot faster is to recognize that there are 2 zeros in 100. So all you have to do to make this number bigger is move the decimal to the right, the same number of zeros that you have here. It's the number of places that you have zeros. 2 zeros. We want it bigger, so we're going to go 2 right. 1, 2. There's the decimal. So the answer is 30. So keeping that in mind, watch this one. We're going to times this by 10,000, which means we're going to make it a lot bigger. 10,000 has 4 zeros in it. So let's move this decimal 4 places. To make it bigger, we move it to the right. 1, 2, 3, 4. Put your decimal, use 0 as placeholders. And there you have it. 8,787,400. This is actually the same thing as scientific notation. If you ever heard of scientific notation, this is what's going on. Now that's not that big a deal because it's really easy to multiply by 10,000. You just basically write down 4 zeros and then multiply by 1, and you count decimals. Let me do that right quickly. You can multiply by any powers of 10 since there's 4 zeros. And we'll write those down, and 1 times that number gives us that same number. There's only 2 numbers after the decimal, so I need 2 numbers after the decimal in our answer. So there we go. It's the same thing. So either way is fine. It's however you want to do it, or if you just want to do it the long way by hand, that's fine also. But division, I strongly recommend what we're about to do, or multiplication with powers of 10. It doesn't matter. I'll stick with something else. You can do this one the traditional way. Ignore the decimals. 3 times 1 is 3. Count decimal, or count digits. 1 there, 2 there. Grand total 3. I already have 1. I need 2 more, and you're done. Now if you want to see a faster way, or a different way, maybe a little bit faster, we're multiplying 0.3 by 0.01. This works for powers of 10. 0.01 is actually a negative power of 10. So what that means is it's going to make the number smaller. To make this number smaller, by moving the decimal, we have to go 2 places, or we have to move it left. The reason why I said 2 places is because there's 2 numbers after the decimal. So the shortcut way is to take that 0.3. Notice there's 2 numbers after the decimal, and you move the decimal 2 places left because that makes it smaller. There you go. Same as that. So on this one, you notice there's 1, 2, 3, 4 numbers after the decimal. Since that's a really small number, when we multiply that by this number, it's going to make that one even smaller. So that means we need to move the decimal to the left in the number to make it really small, or to make it smaller. 1, 2, 3, 4 places. Move it 4 because there's 4 numbers. The one is 0. And you're done. Once again, you don't have to do that if you don't want to. It's just as easy as to take 1 times 878.74 and count places. Now, one of the main applications that we're going to consider when it comes to multiplying decimals is the circumference of a circle. Let's talk about a circle for a second. Circumference is the distance around. So if you have a circle and I ask you for the circumference, I'm asking you for this distance all the way around back to the starting point. That's called circumference. What you see to represent that. There's 2 main formulas to use. C equals pi d, or C equals 2 pi r. Now you need to understand what these variables are. If you look at the circle, if you go straight across the circle, that distance is called the diameter. We'll use d to represent that. R is halfway across the circle. That's the radius. The radius is the distance from the center of the circle to the outside edge, and what makes a circle circle is that radius is the same all the way around. So what that means is that half of the diameter is the radius. So one way to relate those two radii equals 1 diameter. But the way you're typically going to use it is, if you're given the diameter and you want to find the radius, you're going to take half of the radius, or divide it by 2. Now you can use this formula or this formula. They're the same. Pi is an irrational number whose decimal never ends or repeats. And what we'll typically use to approximate it is 3.14. It's an approximation. It's not equal. It's approximation. By definition, it's the ratio of the circumference of a circle to its diameter. So, you're going to find out, I always use this one, because all the other formulas that involve circles have R's. Now, let's complete this problem that was first asked. Find the circumference of a circle with radius equal to 10 centimeters. And so, to do that, I'm going to use C equals 2 pi r. I'm always going to use that. And since we're given the radius is 10, and we're going to approximate pi with 3.14, we're just going to substitute those in. And that's basically all you're doing. Now we're going to multiply the numbers. 2 times 3.14 is 6.28. 1 times it by 10. And so, when you multiply it by 10, you can just write down a 0 and then multiply 1 by 628. You get that. 2 numbers after the decimal. 2 numbers after the decimal. And we're done. Circumference equals 62.8 centimeters.